Okay, let's close out this chapter by looking at just examples of how adaptations are thought of. This is not necessarily for health, but this is the traditional incremental adaptation cycle with transformational considerations added. So just like when we said communication can be just to make people aware of, let's say, climate change, or it can be to engage them in action like reducing plastic waste or avoiding deforestation or whatever, or it can be complete behavioral change where you're expecting people to give up eating meat and so on and so forth. So adaptation also can be incremental to just deal with reducing immediate vulnerabilities, or it can be transformational. So traditional incremental adaptation, let's say the steps are shown here. Identify problems and objectives. So do incremental changes remain sufficient? Probably not. Then you have to assess and initially appraise transformative options, acceptance and preparedness to change. And then you feed it to the second step to establish decision-making criteria, receptors, exposure units, and risk assessment endpoints. If the incremental changes in fact remain sufficient, then you can skip this test step and get to here. In the third step, you assess risk, you identify options, and you appraise options, and you have this iterative process to come to making decisions. And if decision criteria is met, then you have to go back to the second step and go through the iteration again and come back. If yes, is problem defined correctly? If yes, you go to implementing decisions and monitoring and back to the identifying problems and objectives to see if your goals have been met. If not, you have to go back here and go through the process again. Okay. So somewhere you have opening for introducing decisions either to move to a transformative change or to await an appropriate trigger to change or to remain on the path, right? So you have to have those kind of flexibility in the system, but there are also systems which are seen as transformative. So here you have magnitudes of human impacts. As they increase, you need to obviously respond appropriately in terms of dealing with magnitude of climate change response. So if you have, for example, this is a agricultural system, let's say. Inaction means suffering harvest losses. If you're coping, then you are applying fertilizers and watering plants and trying to deal with magnitude of human impacts and climate change response and crops and so on. Incremental adaptation would bring you to diversifying livelihoods and building irrigation, managing water resources, dealing with extreme events. Whereas transformative adaptation would require migrating or converting land to other uses, and that would then require amount of investments, human, financial, and time, plurality of stakeholders, sectors, and levels, divergence from status quo and current power dynamics, degree of uncertainties and risks have to be dealt with as magnitude of climate change impacts and required responses go up. Changes in values, framing, and assumptions would be needed. Obviously, you can transform this argument for health impacts as well, and that's the point of how adaptation options have to be considered in the context of climate change impact on health. We come back to vulnerability. So if you want to do transitional or transformative adaptation, you have to do vulnerability mapping and other issues like e-health and costs of health that you are dealing with climate change as well, right? So let's say we want to do vulnerability mapping at scale, could be at municipal level. So this is an example of municipal vulnerability index. and you have to consider climate scenario indices. So climate anomalies, this is done here with the Hadgem model with a scenario of RCP 8.5, which we talked about in terms of the business as usual scenario with the highest emissions into the coming decades into out to 2100, and top of the atmosphere radiative imbalance of 8.5 watts per meter squared. Vulnerability indices we have talked about several times, looking at adaptive capacity, sensitivity, and exposure, and include various things like vegetation cover, index of natural disasters, diseases associated with climate index, poverty, socio-demographic, socio-economic, institutions, services, infrastructure, socio-political, and then of course temperature and precipitation indices. Essentially, you cannot do transformational or transitional adaptation without worrying about detailed vulnerability mapping. Here are some examples of health system activities in Europe to address infectious disease risks under climate change. So there are indicator-based surveillance, collection of trend analysis and interpretation of data. So routine data analysis, pharmacy-based monitoring, sentinel surveillance that we talked about, vector surveillance, real-time surveillance, mortality from infectious diseases, syndromic surveillance that we talked about. So that includes monitoring emergency room admissions for symptoms indicative of infectious diseases. Okay. Event-based epidemic intelligence, early identification of infectious disease threats, which include screening of international news media and other sources, case reports, science watch, interdisciplinary reporting of infectious disease threats, for example, from agriculture, industry, environment, and so on. So these are already things that are happening in Europe, which is usually ahead of the curve in terms of dealing with climate impacts, both in terms of mitigation and adaptation. Okay. The other thing that is involved in immediate adaptation is, of course, what we already talked about in terms of early warning systems, right? This is, you can think of it as what we called traditional incremental adaptation, or you can think of it as part of the transformational adaptation, which will keep feeding into the digital health and planetary health and other concepts we have already introduced. So here we are trying to use forecast skill at various time scales, from weather forecasts and subseasonal to seasonal forecasts and seasonal outlooks. So that goes from 1 to 10 days, 10 to 30 days, or often referred to as weeks 2 to 4, or 30 to 90 plus days, could be 6 months to a year. Did I screw this up again? Okay, here. So this is the ready, set, go framework we had talked about. So reliable and actionable information for decision making is produced at short and medium range, so 1 to 3 days, 3 to 10 days, and extended range, weeks 2 to 4, and long range or seasonal outlooks, often referred to as seasonal to interannual, because it can go to 12 months or longer depending on the skill, like El Nino prediction, for example. So here you are trying to deal with issuing early warnings, distributing humanitarian aid, evacuation, and there are many S2S weather influenced actions. I won't go into the details because we looked at it earlier, but you can see how multiple timescales are being dealt with, and the long range weather influenced actions include monitoring forecast, updating contingency plans, informing strategic planning decisions, and altogether feeding into financial risk strategies, loss scenarios, peak energy demand scenarios, pre-positioning of disaster response materials, implementing irrigation, pesticide, and fertilizer schedules in terms of food production, nutrition, and other health-related decisions. And the other part of the transformational or transitional adaptation has to include the so-called e-health or digital health. And I just took this as an example from Iberdrola, which is a company that does lots of things from sustainable energy and so on and so forth. This is taken from Deloitte's report, but you can see the various aspects involved in e-health or digital health. So if you have lots of data on health and climate, you would use artificial intelligence, learning platforms, natural language processing, Internet of medical things. You heard about Internet of Things for controlling your house, your car, your security, your bank accounts, etc., etc. But this is Internet of medical things. Blockchain systems that we talked about for secure data management and transaction tracking, robotics, interoperability and open code platforms, big data analysis, which is related to artificial intelligence, cloud-based IT solutions, business applications, sensors to monitor indoor, outdoor air quality, water quality, health of people, 5G technology networks and data platforms and so on. So obviously a little generic, but this is really beginning to be part of healthcare systems and is the future of managing adaptation of health. Of course, costs and future costs are part of the worry as well in terms of adaptation. So this is an example from World Health Organization, which is looking at climate impacts and looking at expected outcomes by 2030. Deaths from diseases like malaria, malnutrition, diarrhea, and heat stresses are expected to hit 250,000. 7 million deaths from air pollution, additional premature deaths. Temperature and disrupting precipitation patterns and frequency and intensity of extreme weather events are going to, together with health, going to add additional 2 to 4 billion to dealing with health impacts. Hunger, famine, and famine will increase as food production is destabilized by drought. Vector-borne diseases like malaria and dengue virus will increase with more humidity and heat, which we talked about. So adaptation has to include also additional costs that are going to be incurred because of climate change. As usual, we have to highlight the co-benefits of adaptation. This is just an example from the Lancet, which is talking about co-benefits of doing climate adaptation in terms of power, industries, transport, buildings, fuel supply, and non-energy sectors like agricultural solvents and waste management and so on. We're going to improve air quality. So here, sulfur dioxide, you can see the various relations and the color codes here. So what contribution will come to reduced sulfur dioxide from power, from industry, from transport, buildings, fuel supply, and so on are shown here in the pie chart. Nitrogen oxides, particulate matter, carbon monoxide, volatile organic compounds, which go into producing more tropospheric oxygen, ozone, which is really bad for health as well as for crop yields, and of course ammonia. Almost all of it is going to come from agricultural solvents and waste, right? So adaptation costs in terms of return on investments have to be looked at in terms of co-benefits. So that's what is going to require synergistic planning with climate adaptation and mitigation and health adaptation and mitigation, and the co-benefits to all of the systems. Okay, so that's a short run through in terms of climate change mitigation and adaptation leading to health risk reduction, vulnerability reduction, and required health adaptations, and the needs and options of adaptation for reducing health risks. Okay, lots of details can be obtained from the long list of references provided at the end of the chapter. So if you are more into adaptation for health, then you must follow up all those these podcasts are just meant to give you an overall starting point for summarizing the chapters. Okay, so build your own details based on your own interests and research needs. Okay.